Hey guys, welcome to our short video on interval notation. Okay, so this applies to anything that you ever need to write as an interval in any of my classes, Math 95 and higher. Okay, it's a very simple process that is really kind of nice and streamlined, makes things really easy as you get further and further, especially as you do more and more complex intervals. But it can be something that when you're starting out can be kind of difficult. So let's talk about the three basic components of interval notation. Okay, our three basic components are start points, start points, our endpoint or endpoints, and lastly our closing slash opening symbols. Okay, so interval notation, this is really what it consists of. Okay, we have some place that we say to start at, we have some place we say to end at, and then we have some symbols on it that tells us kind of whether we include or don't include those points. Okay, so interval notation is always done smallest to largest. Okay, always smallest, comma, largest. Now remember, -5 is smaller than 4. Even though 5 is bigger than 4, but -5 is smaller than 4. Okay? So, there's our basics. Let's talk about kind of what those pieces are. So there's a few symbols I want to introduce. Okay. Now you may be more familiar with number lines, with doing the open or closed circles, or maybe inequality notation using like less than or greater than, or less than or equal to, greater than or equal to. Okay, and we can use those to help kind of tie in our knowledge from that stuff into this new interval notation with our end symbols. Okay, so if we have, what would be an open circle in a number line, okay, that's the same as kind of a less than or a greater than. Okay, and what these are going to represent, what we're going to use for those in interval notation is parentheses. Okay, so a parenthesis is what we use in these cases. And what this means is we are going to go up to, if it was the closing, or similarly down to, if it's our opening, right? So if it's our opening bracket, we're going to go down to that value. Okay, but not including. So this parenthesis means that we're going to go all the way to that number, almost infinitely close to that number, but we will not actually equal that value. Okay? And so one way to think of this is walking to a door, going halfway every time. You're going to get infinitely close, but you theoretically will never actually get there because there's always going to be half the distance that you had left to go. That may be a little too philosophical or theoretical for you guys, but it's fine. Our other symbol that we do with a filled in circle, which this is a big circle to fill in, which is the same as a less than or equal to, or similarly greater than or equal to, we will use square brackets for that. Okay, so square brackets in interval notation are the same as a filled in circle or less than or equal to, greater than or equal to. And what this means is that we go up to or down to, depending on whether it's an opening or closing bracket, and including. So brackets mean we include those values. We're going to go all the way to that value and actually equal that value. Now, a little mind trick I use on myself, not mind trick, but like a memory trick that I use to help me remember this, shocky, is I think of a boxcar. Like I think of a number line, and it kind of looks like train tracks, right? And so I think I have my hand as a boxcar. Okay, it's square. If I make my other hand into a parenthesis, when that boxcar drives in, there's always that little gap in there, right? Even if I make my parenthesis really wide, there's still a gap. I can still see you in there, okay? But if I make my hand into a parenthesis, that boxcar fits all the way in. There's no gap. So parenthesis is when we can go all the way. If we make it really big, we can get really close to it, but we can't actually get all the way back in there. But if we have that square bracket, it comes all the way home. Okay? That's my little memory trick to help me remember what I'm doing and how it works. All right? So, let's do some examples. All right? I want to do, very simply, we'll start with number lines, and then we'll write the inequality version, and then we'll also write our new interval notation. Okay? And let's just say I've got a really simple, say, -7. We will include that one. And we'll go up to 1. And we'll include that one. Okay? Well, very simply, using inequality notation for things like this is pretty easy, because we can just say, oh, well, that just means it's -7 is less than, because it's filled in, it's less than or equal to, say, x less than or equal to 1. Bam! That's it. That's easy. Interval notation is pretty simple as well. Remember, always smallest to largest. Okay? So interval notation is written like an ordered pair. Okay? So we have smallest, comma, largest. So that's how we're going to do this. So the smallest value is -7, comma, our largest value is 1. Now, since these are filled in circles, that means we're using brackets on both. So, bam, there's our interval notation. That's it. That's how easy it is. That's how simple this is. Okay? So let's do another one. I don't have a lot of room. I don't want to squat down, so let me erase. What about this? This is saying everything greater than 1. Okay. So that's easy, right? Interval notation is really easy here, right? That's just x is greater than or equal to 1. It's easy. Now, how do I do this interval notation? I need a smallest and a largest. Well, my smallest is obviously got to be 1, right? But what's my largest? Like 100 billion? Right? No, remember, this goes off to where? To infinity, that's right. So if this goes off to infinity, we go from 1 to infinity. Now we need to forget our end symbols. Well, this is a closed circle again, so closed circle is bracket. So it's opening, right? We're not going to put a bracket like this. That's silly. Can't really see that. We're going to have a bracket like that. Now, what about infinity? Do I ever include infinity? Does infinity get a bracket or does it get a parenthesis? Well, is infinity actually a number? No. Infinity is an idea, a theory, if you will, right? Or this theoretical construct. It's not a number, which means we can never equal it. We can never include it. Infinity always gets a parenthesis. And it's that simple. Okay? So there's another easy one. Let's make it a little more complicated. That's not too complicated, but let's do it anyway. So we have everything less than 4. Okay, well, that's easy. It means x is less than 4. It's open circle, so we're not including it. We're not equal. So x less than 4. Well, okay, so then the smallest value, well, this goes off to negative infinity, right? So we get negative infinity. It goes up to 4. Do we ever include infinity? No, that applies to negative infinity as well. What about 4? Well, it's open circle, parentheses. These are getting easy, guys. You guys are cruising through this. All right. Now this one's going to bring up a nice, interesting point. This interval here from 3 to 7. Interval notation. Inequality notation. 3 is less than x is less than 7. Easy enough. Interval notation. Smallest is 3. Largest is 7. Both of these are open circles, which means they are both parentheses. looks like the 0.37. How do I know if I'm talking about the point 3 comma 7, or if I'm talking about the interval from 3 to 7, not including 3, not including 7? Well, the very simple answer is the context of the question. If I ask you, say, what's the domain of the function, and you give me this, I'm going to assume that you're talking about the interval from 3 to 7, and not that you think the domain is the singular 0.37. Similarly, if I ask you, what's the highest point of this function, and you say 3, 7, I'm not going to think you mean the highest point is from 3 to 7, but that the highest point is the 0.37. Okay? So the context of the question tells us whether this is an interval or an ordered pair. And that's really as easy as it gets. Now, we're going to do one more example with you guys. And this brings in a new symbol. Our new symbol that we're going to use looks like a big tailless U. And what this stands for, we call this the union. And what this does, okay, is this joins two separate intervals. Okay, so this is how we join two separate intervals to create one set. And so let's look at an example. Let's see here, let's say we go this up to, we haven't used 0 yet, so let's include that. And let's also go from 4 to 8. Okay? I have two pieces. I have this piece here and this piece here. I really have two intervals. And so the way we do this is really we do what we've been doing just twice, and we add in that union between. So just as one interval goes from smallest to largest, if I'm doing multiple, I want to go from the smallest of the intervals to the largest of the intervals. So I'm going to start with this one, which goes from 0 down, so it's just negative infinity, right? And you don't have to wait until the end to do your symbols. You can do this as you go if you're comfortable. So it's 0, negative infinity. 0 is a closed circle, so we're going to get 0 bracket. Now this one here starts at 4. It doesn't include it. It goes to 8, and it includes it. Now I want to write these as a single set. So what I do to join these two intervals is I just put a union. That's it. That's all we do. Easy. You can tag these on 15, 20 sets. Now what if I want to do this in inequality notation? Okay, well, I'm going to squat down here. An inequality notation for this would look like x is less than or equal to 0, or 4 is less than x is less than or equal to 8. Which one of these do you want to write? Okay. They're not like crazy cumbersome. It's not like it's an essay versus a single word, but this just gets to be a little easier, a little better flow to it as we go. Now I want to do one more example. I know I said that was the last one, but I lied. One more. What about this? Well, this is everything except 3. Inequality notation, we could be pretty easy. We could kind of do these in pieces where we could just say x does not equal 3. But how do I do this in interval notation? And we have to recognize that this is still two separate intervals. They just share this point. Okay? And so this first interval goes from negative infinity to 3. Right? We never include infinities, either negative or positive, and 3 has an open circle, so we're not going to include that. Now we need to join this up with another one, so I'm going to put my union in right away. I know I'm going to need that. And now where does my next piece start? Well, it starts at 3 as well. Again, it's open circle, so I'm not going to include it. And it goes off to infinity. So what this says is, this says take everything from negative infinity up to 3, but don't include 3. Then start at 3, but don't include 3, and go up to infinity. Okay? So this is what we do for this. Okay? If you ever do something where you have something stopping at one point, not including it, and then you have like a bracket over here, that means there was no need to stop that. That's like saying, okay, I want to get over to that book, so I'm going to walk to here, but not all the way to here, and then I'm going to start back and get to here. I could have just said, okay, walk to the book. right? And that's what we want to do. We want to be as simple and concise as possible. So if you ever have something where you don't include the exact value and then include that exact value in the next piece, that's just one piece, okay? That's interval notation. Hopefully you guys understand that. There's going to be some questions on it in whatever class you're in with me. I guarantee you I'm going to have questions on it. So make sure you guys understand this. This is how we want to write everything. Interval notation. All right, you guys. That's it for this lesson. I'll see you next time.